Welcome to Longevity Verified. I'm Dr. Tom Graham, a cardiologist and a general medicine specialist. For most of my career, I've worked where medicine is at its most intense, emergency departments. I've spent nearly 20 years practicing medicine across the United States and Europe, and for the last decade here in the NHS. And after years of treating crises, heart attacks, strokes, sepsis, I came to a simple conclusion. The biggest opportunity in modern medicine isn't just saving lives in the moment, it's extending the healthy part of life, health span, by preventing disease earlier, and by using new tools that simply didn't exist when I started training. Quick note, this channel is for education, not personal medical advice. If you have symptoms or medical decisions to make, talk to your own clinician. This channel is about what's genuinely changing in medicine right now. Longevity, aging biology, cardiovascular risk, cancer prevention, new therapies, and the technologies reshaping all of it. No hype, just truth, and what it means for you. In this first video, I want to show you what I mean by longevity verified, with 6 breakthroughs that in 2026 are quietly redefining human longevity in healthcare. First, medicine is going through what I call the programmatic turn. For decades, healthcare has been reactive. We wait for people to get sick, then we treat the consequences, often late, often expensively, and sometimes too late. But now we're shifting from simply digitizing records to making clinical care intelligent. We're starting to treat the body less like a black box and more like a system we can measure, model, and carefully modify. Breakthrough number 1, your organs do not age at the same speed. A major Nature Medicine study used blood proteins from almost 45,000 people to estimate the biological age of 11 organs: heart, brain, liver, immune system, and more. The headline isn't, "We found a new clock." It's what the clock reveals. Your body is a mosaic. One organ can be aging fast while another stays relatively young. And in that study, the brain and the immune system stood out as the strongest signals for long-term outcomes. People with a youthful brain signature had a much lower risk of Alzheimer's, independent of key genetic risk variants. And when both brain and immune system looked biologically young, long-term mortality risk was markedly lower. What does that mean practically? The future of prevention won't be one size fits all. It's going to be organ-specific, targeted screening, targeted risk reduction, and, eventually, targeted rejuvenation. Breakthrough number 2. Sleep may be a metabolic reset for mitochondrial stress. There's a beautiful piece of science from 2025 looking at fruit flies. Yes, flies, but the mechanism is elegant. The researchers showed that sleep pressure may build when certain neurons' mitochondria become overcharged and start leaking electrons, creating reactive byproducts. When they uncoupled energy flow from ATP production, basically creating an energy leak, the flies felt less pressure to sleep. Push the mitochondria harder, and sleep pressure rose. Translation to humans is not automatic, but the concept is important. Sleep may not be rest in a vague sense. It may be the brain's way of forcing a cellular reset before metabolic stress causes damage. Breakthrough number 3, early signs that some aspects of tissue aging may be reversible. One of the most interesting themes in 2025-2026 is the idea that aging has a direction at the cellular level. Researchers have described a broad pattern they call mesenchymal drift. With age, many tissues shift away from stable, specialized cell states and towards stiffer, scar-like programs associated with inflammation and fibrosis. In mouse models, partial reprogramming, short controlled exposure to so-called Yamanaka factors, can move some gene expression patterns in a more youthful direction in tissues like liver and kidney. This is not a consumer therapy, it's not ready, and it comes with real risks: uncontrolled growth, loss of cellular identity, cancer. But it changes the conversation. Aging isn't just wear and tear. Parts of it look like a biological program, and programs can sometimes be edited. Breakthrough number 4, AI is moving from chatbots to agents. Most people saw AI in medicine as a chatbot. You ask it a question and it answers. But the next phase is autonomous or semi-autonomous agents, software that can observe, plan, and execute tasks inside defined guardrails. In practice, that can mean pre-visit summaries that actually make sense, drafting clinic letters, pulling key results from the record, flagging deterioration from remote monitoring, and reducing the administrative overload that is burning clinicians out. This is powerful and risky. Autonomy without governance is how you get quiet errors at scale. So here's my rule for this channel. If AI is involved, we talk about accuracy, bias, data quality, accountability, and what happens when the model is wrong, not just the glossy demo. Breakthrough number 5. The economics of medicine are changing. N of 1 therapies are becoming real. For decades, drug development economics meant one thing. If your disease was ultra-rare, you often didn't matter commercially. In late 2025, the FDA described a new plausible mechanism pathway aimed at bespoke therapies for conditions so rare that classic randomized trials aren't feasible. And around the same time, the FDA approved Wiskyra, a gene therapy for Wiskott-Aldrich syndrome, with a nonprofit organization behind the approval. That's a signal of a new model. Platform technologies, smaller data sets, tighter mechanistic reasoning, and post-market evidence. It's not a free pass. It's a trade-off. But it could pull personalized gene and cell therapies out of science fiction and into clinical reality, first for the rarest patients and later for broader disease. Breakthrough number 6, digital pathology at national scale, turning biopsies into data. If you've never seen a modern digital pathology slide, here's the scale. A single scanned slide can be so information dense that if printed, it would cover something like a tennis court. This isn't just convenience, it's a structural change. It allows remote second opinions, crucial in specialties with limited expertise, and it creates data sets large enough to train AI systems to detect patterns associated with cancer and treatment response. In the UK, programs like NPEC are building the infrastructure to do this at scale. Done well, it can reduce geographic inequity. Expertise can travel instantly, even when people can't. Done badly, it can amplify errors. So again, we focus on validation, standards, and what clinically safe actually means. So that's the point of Longevity Verified. We're living through a convergence, better measurement, organ-specific aging and risk mapping, new biology, partial reprogramming and gene editing, new delivery systems, AI-assisted, scalable care, and new regulation and economics, making personalized therapies possible. My job on this channel is to separate signal from noise. In every video, I'll aim to answer 4 questions. What's new? What's real today? What's likely next? And what should you do right now to protect your future health? If that sounds useful, subscribe. And in the comments, tell me what you want unpacked first. CRISPR and gene editing, cancer vaccines, longevity biomarkers, cardiovascular risk prediction, or the practical basics, sleep, exercise, blood pressure, and metabolic health. Done properly and without nonsense. One last thought. If a blood test could map which organ is aging fastest and point to your risks 15 years ahead, would you want to see that map? Welcome to Longevity Verified. No hype, just truth, and a clear view of where medicine is leading us. Stay curious. Stay skeptical. Stay Longevity Verified.